Welcome back, guys. Today is day 2 of week 7. Let's continue working with the topic that we started yesterday and the day before. So we were seeing the formulas for perfect squares and difference of squares. We learned that if we have the sum of a perfect square, it would be a monomial plus another different monomial, and that inside of parentheses to the square. And we were going to identify A and B, and then use the right part of the formula in which both of them were positive, and we got the first monomial to the square plus 2 times the first times the second monomial plus the last monomial to the square. And we said that the only difference for a difference of perfect square is this sign, that in here it is negative. We also learned the difference of squares formula for special cases, okay, where we have the addition between two different monomials multiplied to the subtraction between those same monomials. So they're basically the same terms, but one has an addition and the other one has a subtraction, or one has a subtraction first and the other one has the addition. And this is the only scenario where you're going to have an addition of a binomial, okay? A subtraction, and it is a binomial. It's the only case, and we have a to the square minus b to the square. So right now we have 4 examples. Remember that before this topic, we saw just multiplying binomials, and we used FOIL method, where we multiply the first term of the first parenthesis times everything inside the second parenthesis, and then the second term times everything inside the second parenthesis as well. So we have a little bit of everything in here. Probably we are going to determine what method we're going to use, if we're going to use one of the special cases formulas or we're going to use FOIL. Okay, so that's what we're going to be doing today. So exercise 1, x minus 11 times x plus 11.
It's number 3.
Formula number 3, correct, because we have one negative, one positive, and the terms are exactly the same. So let's identify A and B. What is A?
X.
X, and it doesn't matter from what parenthesis you determine that, because you're the same thing. How much is B?
11.
11. So just remember that we're going to use the right part of the formula. So I'm going to copy it down here, and then I'm just going to substitute the values that I found to be A and B. So instead of A, X, and that goes to the square, minus, instead of B, 11, and that also goes to the square. Now we just go ahead and simplify. How much is X to the square?
X squared.
X squared. Minus, how much is 11 to the square?
11 to the square.
How much is that? You need to simplify.
Negative 22.
Nope, it's not 11 times 2. How much is it?
11 times 11.
How much is that?
It's 110. Well, 100 100 and
121.
121. And that's it. That's the final answer. Very good. So it is 121. That's it. That's all that we have to do. So something like that will be the classwork that you will be doing. Okay. Next one.
The next one is number 1.
Next one is formula number 1, because it is 1 parenthesis to the square. Very good. So I'm going to copy this before, so I can have it down here. And now I'm going to identify A and B. How much is A?
H.
Very good. This is A. How much is B?
B.
3.
3. Now remember, this too is part of the formula, okay? So we're going to say A is H. So that would be H to the square plus the 2 of the formula times A, that is H, times B, that we determined it was 3, plus B to the square. And B to the square would be 3 to the square. Now we simplify that. How much is H to the square?
H to the square.
H to the square. Plus, how much is 2 times H times 3?
Is 6H.
6h.
2h.
Why? Because we multiply the 2 times the 3 and then times the variable h. Since we don't know the value, we just copy it like that. Plus, how much is 3 to the square?
9, very 9, so
9. Very good. Remember, it is 3 multiplied 2 times, not 3 times 2. And that was my final answer. Instead of doing FOIL in this, then we just use the formula. Easy peasy, breezy, lemon squeezy, right? Okay, let's see. Are you ready? Someone that's not Alfred, what formula?
3
what
is
method
number
do we
2.
use?
Number 2.
Yes, Alfred. Formula number 2. So I copy the formula, copy it down here, and let's identify A. This is A, right?
Yes.
No,
No, that is B. That
B.
is B. And
Ah.
4K is A.
Very good. So this is A, and you said that this was B. Very good. Now, let's substitute. So we're going to have 4K, and that goes to the square, minus the 2 of the formula, times 4K, times 1, because 1 is B, plus 1 to the square. And let's simplify that. What should I do to simplify this part over here?
Power of a power.
Power.
Powerful power, very good. Where this square will affect the 4 and will affect the K. So how much is 4K to the square?
16K to the square.
Very good, 16K squared. Because 4 to the square is 16 and K to the square is K squared. Minus 2 times 4K times 1.
8K.
8K, very good. In this case, it is just K, 8K because this is a 1. If not, it would have changed, right? Because we multiply the 2 times the 4 times the 1 and then times the K. Plus, how much is 1 to the square?
1.
1. Remember, 1 to whatever exponent, it will always be 1. So that's my final answer. Easy peasy, breezy, lemon squeeze.
The last one, I think, is FOIL.
Are you sure it is FOIL?
I think because the 3x not is the same that the 2x.
Ah, okay. So just because this is a 2x, it means that this cannot be solved with a formula because we need the formula to have exactly the same terms. Very good. So we're going to do FOIL in this method. So sometimes we use a formula, sometimes we use a distributive method that we're going to call FOIL, where we multiply the first term of everything inside the second
Miss,
parenthesis.
question. You're making distributive property to the sign plus.
It doesn't matter. Just move it a little bit to the other side, okay? There. That doesn't matter, okay? It's just for you to know that you're going to multiply 2 numbers, okay? So the same thing goes with the -4 and there. So we're going to multiply that and we're going to find out how much that is, okay? And you can see they have exactly the same exponents. So what does that mean? When the terms have
You
exactly
add the exponent.
The exponent.
You multiply the coefficients and add the exponent to.
yeah, exactly. But
part.
once that you do that, once that you do the distributive property, you will get a 4-term polynomial. So if they have exactly the same exponent,
You simplify.
you're gonna have exactly the middle terms to be like terms. So let's multiply. How much is 3x times 2x?
CX to the square.
6x to the square.
6x to the square. How much is 3x times 4?
12x.
Negative 12x.
Negative 12x?
No,
No, es
12x.
que escribí mal yo el ejercicio.
Positive,
Perdón.
12x. Now negative 4 times 2x.
Negative 8x.
Negative 8x. How much is negative 4 times 4?
Negative 16.
Negative 16. And we just said that the middle terms were going to be
You
like
simplify
terms.
12 and 8.
Very good. Because
Like terms.
Exactly, they're like terms. So I'm gonna have final answer as 6x to the square, 12x minus 8x.
It will be 4x minus 4x.
Minus 4x,
No, 4
Okay.
4x.
Negative
4x.
4x.
positive
X
4x.
because the positive because the
Positive.
12 is bigger.
Very good, because the 12 is greater. Minus the 16. And that would be everything you are going to be doing. Okay, I have a
So
question
today
here.
we're gonna do a classwork, Miss.
Yes, I have a question in here. How do I know when I have to use the FOIL or formula method?
Yes, miss, you use the foil when you have, bueno, el foil you use when you only have two parentheses like that. And
Different.
the second parenthesis, you have a different exponent or number or variable that the first parenthesis doesn't have.
Exactly. So just to recap what Alfred said,
Two parentheses
we are
that are
going
not
to
the
use
same.
FOIL when both binomials are different. They have different monomials. 3x is a different monomial from 2x, even though 4 is equal to 4. But we have different binomials. It is not the same thing, 3x minus 4 as 2x plus 4. We are using formulas when we have one single parenthesis to the square or the same binomial is repeated. Okay, like for example, it would have been here h plus 3 times h plus 3. They are exactly the same thing. So, sorry. So we know that this means the same thing as this. This is the same thing as saying h plus 3 to the square. Okay, so we use formulas when we have the same binomial multiplying itself or the binomial to the second power, or the only thing that changes is one sign. One is added and one is subtracted, but they're exactly the same terms, okay? H and H, 3 and 3, except one is added and one is subtracted. In this case, they are completely different because this is 3x and this is 2x. So we use FOIL. Does that clear out the question?
Yeah, Miss
Okay.
number one, what is the word you're doing? Like exactly, I don't understand.
Okay, one more time with exercise 1. As you can see, we have x and 11 and 11. One is added, one is subtracted. It doesn't matter if the first parenthesis is the addition or the second one. It doesn't matter where the addition goes, as long as they are same terms, but one positive and one negative. Okay, so we use this formula, difference of squares. We identify A and B from whichever parenthesis you want. Could be the first one, could be the last one, it could be from 1 and 1, it doesn't matter. As long as you identify A and B. Always A is from the sign to the left and B is from the sign to the right. And we just go ahead and substitute it in the right part of the formula, where A squared minus B squared is the solution of this. Instead of doing FOIL, we just go ahead and use the formula of difference of squares. So we got A is x, so x to the square, minus B is 11, 11 to the square. And then we just go ahead and simplify x to the square, x squared. And 11 to the square, remember it's not 11 times 2, it is 11 multiplied twice. So it is 11 times 11, which gives you 121. We clear now?
Thanks, Miss Nina.
Are we clear? Yes?
Yeah.
Okie dokie then. So basically, this is what we were going to be doing. Just a little bit more of exercises. Let's do some more. We still got time. I'm going to copy some exercises. You guys are going to be solving it by yourselves first, and then you're going to let me know what method did you use, okay?
That's a number or that's a sign?
This is a 5, exercise 5, and this is z minus 3. Let's do it again. So exercise 5, z minus 3 times 3 plus z
Miss, I don't understand when I use each one.
I'm sorry?
I don't understand when I use each
You,
each.
but you did it in here. I just explained it. You need to see if it is the same parenthesis multiplied twice, or if the parenthesis to the square, and you use either of this. Just focus on the signs that you got. If it is exactly the same thing with one positive and one negative, or one negative, one positive, then you use the difference of squares. But if it's completely different, you use FOIL. This is a z, okay? Z minus 3 times 3 plus z. 2m minus n times 2m minus n. W plus 2 times 3w minus 4. And the last one is going to be 3b to the square plus 5a to the cube, and all of that to the square. Those are the 4 exercises that we're going to continue to do now. First, we're going to determine if we use a formula or not. And I'm just going to place over here 1, 2, 3, or an F, so you can know how you're going to do it. So exercise 5, should I use formula 1, formula 2?
No, Miss, wait,
Or
Miss, que no he copiado la 8.
English. So just
We need to
Bueno,
copy all of them,
la 5
or just
is formula number
English.
3.
Formula
Number 5,
3.
number 3.
Do you think
Yes.
that's true?
Yes,
Why
true.
not? Why?
Because there are same numbers with different signs.
Exactly. They're just located differently, but you can rearrange this in order to have the variable first. Okay, exercise 6.
Exercise 6 is number
it's
2.
like number 2.
Formula number 2, because it is the same thing as saying 2n minus n to the square. For number 7,
Foil.
Foil,
FOIL, because they're different parentheses. And number 8,
number 1.
formula 1. And that's how you're going to be solving it, okay? See, you see that you know how to do it? Very good.
Yeah.
The only thing that I'm going to help you out is I'm going to rearrange this. I'm recopying it.
Miss, I need to rearrange.
Okay.
Question.
What's your question?
I need to rearrange the exercise.
If you want, if not, that's okay. This is the exercise rearrange. If you want to rearrange it and then solve it, do it. If you don't want to rearrange it because you know already they're different signs and you can simplify it like that, that's okay. You can do it. I'm going to just rewrite it so you can know what formula is that you're going to write. This is the same thing as this. This is the same thing as this. And this do not need to be rewritten, okay? It only requires...
We need just to write the 5, 6, 7, and 8. Just those one, right?
Yeah, just those one, and you need to solve that. That's okay, Angel, don't worry. Solve those. You already have this 4 because we solved it together. And now you're going to solve this 4, okay? Sebastian, are you working?
Finish.
You finished. Okay, give me the answer of the first one, number 5.
Nah, Milan, number 5, easy. Z to the square minus 9.
C to the square minus 9. That is the final answer. Very good. I'm not going to give you the procedure because you're supposed to have it in there and know how to do it. But very good. And basically, once that you finish copying this exercise, that will, and solving them, that will be everything for today.